My name is C.Thamotharan, Associate Professor, Department of Automobile Engineering, Bharat Institute of Higher Education and Research. I'm going to take a subject name is vehicle body engineering. This course code is Bam702 vehicle body engineering. Second unit, vehicle aerodynamics. I'm going to concentrate. I'm going to take vehicle aerodynamics. Objectives of vehicle aerodynamics. The objective of this project is to conduct a thorough analysis of the car aerodynamics through computer modeling and provide recommendations for improvement. To perform the flow analysis on the baseline model using CFD tool BIHER. To design new model of car, such drag force is reduced. Perform flow analysis on the new models. To achieve better fuel efficiency by reducing drag force. These are the objectives of vehicle aerodynamics. Next, we pass on to types of drag. We have pressure drag, or form drag, or profile drag. It consists 57%. Next, induced drag. It includes 8%. Friction drag, 10%. Interference drag, 15%. Cooling and ventilation system drag, 10%. You can add, it will come around 100%. So pressure drag or form drag alone 57%. You have to concentrate. Pressure drag. To reduce, to increase the stability of the vehicle and also fuel efficiency. Pressure drag alone 57%. As I told you, 57%. Just see that pressure drag, how the pressure is distributing on a car. In front side, high pressure and low speed, accelerating flow. In center, we have the design top. We have low pressure and high speed, decelerating flow, and rear side high pressure, low speed. Typical static pressure coefficient distribution, CP pressure coefficient. We have positive and negative. So typical static pressure coefficient distribution. Okay, A, B, C, D, E, F, G. The area is right. I mentioned A front, B bonnet. Okay, C, D, E, F, G. A 1.01 something. Next one, it comes B side, B point. The pressure coefficient is negative. So nearly 0.09 pressure coefficient. C 0.5. D minus 0.9. Where E 0.30. F 0.01. Where G 0.15, like that. This is the typical pressure coefficient distribution. Next type of drag is induced drag or lift drag. This lift force depends on the contour of the body. Normal speed, not a serious problem. High speed is a serious problem. Lift affects stability and braking performance. Right? It's very important, right? Point. Stability of the vehicle going to affect and braking performance going to getting down. To reduce the accelerated flow upper side, to reduce the deceleration flow underside, will reduce the aerodynamic lift. Next one is friction drag or surface drag, or we call as skin friction. This is caused by friction force between the boundary layer and the body surface. Shear stress generated in the boundary layer. Laminar boundary layer should be maintained. Well polished surface is not only attractive but also makes the vehicle more economical. Body smoothness is of the order of 0.5 to 1.0 micron. The force acting on a surface element. Form drag, force due to static pressure, friction drag. Next, we pass on to aerodynamic forces and moments. The aerodynamic forces on a vehicle in a real environment is as shown in the figure, as shown below. This is for x-axis. Okay, drag D. Side force F, y-axis. Here is z-axis. Okay, lift L. This is for center of lateral force coefficients. Then this is for center of gravity. We have, this is for air velocity Vs, angle, and velocity, vehicle velocity V. Then angle of incidence. These 2 points, this is center of gravity. These 2 points, this is center of lateral force coefficients, z-axis, lift L. Here these 2 points I write, this is for center of pressure. So x-axis is drag D. Alright, aerodynamic forces and moments. The profile of the vehicle is a principal component of the aerodynamic drag and is governed by the way in which vehicle disturbs the gas stream. Its behavior has been found not to accord with the established aerodynamic theory evolved in aviation, since vehicle has to maintain contact with the ground. Next point, the importance of the good aerodynamic parameters in the design of a vehicle is being increasingly recognized. The designer must have knowledge of forces and the laws governing them in order to produce body shapes will have acceptable aerodynamic characteristics. Considering a car profile as an aerofoil, the streamlines around a car body as shown below. Streamlines may have small fan streamlines. The aerodynamic forces on a vehicle act at the center of pressure and summarized as follows: Px. Force of air drag the direction of motion, longitudinal. Py, side force, or cross-wind forces, lateral force, lateral. Pz, aerodynamic lift force, vertical. As these forces are not acting at the center of gravity, but they cause moments as follows. Mx, a rolling moment caused by force. Py about the x-axis, very important way, right? You can understand how the rolling moment is caused. Okay. Next one, pitching moment, My. Pitching moment caused by forces about the y-axis. M is that yawing moment caused by the force Py about z-axis. So drag force Px. The airflow over a vehicle is complex, and the aerodynamic drag is expressed by the semi-empirical equation to represent the aerodynamic effect. It is defined by the following equation. TA equal to 1 by 2 rho v square A CD, where TA aerodynamic drag force Px, kgf, rho air density, kilogram force second square per meter per 4, velocity V, meter per second, A, capital A is a frontal area of the vehicle, meter square, CD aerodynamic drag coefficient, a lift force Pz. The lift force is a result of asymmetrical flow of the air above and below of the vehicle. The lift force affects the vehicle driving stability. Very important one, lift force affects the vehicle driving stability. Loss in control, we say that, loss in control, right? So the lift force is measured at the center of the vehicle, at the center of the wheelbase. Pz equal to, right, 1 by 2 rho v square A Cz kgf, where Cz is a lift coefficient. Side force Py. The side force is formed by the asymmetric flow of the air around the body of the vehicle due to cross-wind forces. That is a flow. The lateral wind components impose their side force on the vehicle to change its direction. Aerodynamic design, side force acts on the body at the center of pressure. Py equal to 1 by 2 rho v square A Cy, where Cy is a cross-wind force coefficient. Rolling, the angular acceleration of the vehicle about longitudinal axis is called rolling. As shown in the figure, rolling, the angular acceleration of the vehicle about longitudinal axis is called rolling, as shown in the figure. The rolling moment. The rolling moment acts about the longitudinal horizontal axis and is produced by the side wind forces. It has only a minor influence on vehicle stability depending on the suspension system. Rm, rolling moment equal to 1 by 2 rho v square A CRM dot L kgf meter, where CRM is a rolling moment coefficient. L is wheelbase. Next, we pass on to pitching moment. The angular acceleration of the vehicle about lateral horizontal axis is called pitching, as shown. All right, just you can see that diagram itself, right? How the effect is. right? A pitching moment acts to transfer weight between the front and rear axis. The pitching moment usually negative, that is nose down. This makes the rear axle lift off the ground and further reduce the available traction. The pitching moment arises from the drag, but the drag itself does not act at the ground plane. The lifting force may not act exactly at the center of the wheelbase. PM equal to, pitching moment equal to 1 by 2 rho V square A CPM dot L kgf meter, where CPM pitching moment coefficient. We know L wheelbase, or we can say characteristics length is meter. So next one, yawing moment. This is also very important, right? We are going to concentrate to reduce yawing moment. Okay, angular acceleration of the vehicle about the vertical axis is called yawing. Angular acceleration of the vehicles about the vertical axis is called yawing. It is the vertical movement of the complete vehicle body. So the complete body rises up and down and no as bouncing as shown in the figure below. Easily can understand how yawing going to affect on your car. Yawing moment. The lateral force caused by a side wind does not act at the mid-wheel base position. A side wind will produce yawing moment, tending to turn the vehicle away from the direction of the motion. Yawing moment is defined as yawing moment Ym equal to 1 by 2 rho V square A CYM dot L. Right, we have meter where so CYM is yawing moment coefficient. L is wheelbase or characteristics length meter. Next we pass on to wind tunnel test. The test section to diffuser and back to compressor are open to atmosphere. We have diffuser and compressor. It's all right. Is the figure shows schematically a wind tunnel. Okay. This one is variable speed fan, guide valve cascade, honeycomb gas section, contraction. This is for working section, searching chamber. Okay. Wind tunnel test. Wind tunnel tests are used to study the aerodynamic aspects like forces, moments, and pressure distribution, drag coefficients, and flow patterns, etc. Wind tunnel tests are used to study the aerodynamic aspects like forces, moments, how the moments to be generated, how the pressure distribution going to affect, drag coefficients, flow patterns, and etc. There are two basic types of wind tunnels. One is open circuit tunnels and B is a closed circuit or return flow tunnel. A wind tunnel is a system or a device wherein provisions are made for air to flow over a scale model of vehicle and the measurement of pressure, forces, Next one, basically the wind tunnel consists of a set up to produce uniform air flow with variable flow velocities. This is achieved by accelerating and decelerating flow inside the wind tunnel and maintaining uniform flow over the working section. The fan is placed in a low speed section, providing a flow of air which is accelerated by providing contraction in the downstream as shown. The guide wall cascades, honeycomb gas sections, settling chambers are provided for directing and damping the flow. The significance of turbulence is reduced. The model is placed in the working section and is mounted in such a way that permits measurement of forces and moments by the transducers. Balance usually mounted outside the tunnel. Pitot tubes with manometers or pressure, velocity, load measurement transducers we can use. The pressure distribution on the model can be found from surface pressure tappings. The diameter of this should be small like capillary or hypodermic tubes. The tappings must be flush with the surface and connected to appropriate manometer or transducer. Such that readings are obtained, and using these values of velocity and pressure, the forces, moments, coefficients, etc. can be calculated. In a wind tunnel, the wind velocity and wind angle can also be measured easily. Okay, I'm going to post a second unit. All right, up to wind tunnel test, right? I have completed second unit. And next, the third unit, you can see later. Okay.